Warning, the following video is rated P for prototype. It contains third-class cuts, scrap wood, guesswork, and other amateur things. Welcome back to the workshop, folks. Today I'd like to show you how I built this battery caddy out of scrap wood. Supplies that you'll need for this build are some scrap wood. I used a 1x6 and some molding, a few magnets, some small flathead screws, a sheet of plexiglass. This was 8x10, and wood and super glue. Tools you need are crosscut saw, marking knife, combination square, a 1-inch chisel, a hand plane and shooting board, and an assortment of drill bits and the sizes listed on your screen. Unfortunately, I got a little excited yesterday and glued these up without filming it, but it starts out with a couple of 2x6s glued together. 2x8 would probably be a great size as well. Now that we've got these glued together, we're going to drill little holes for all the batteries. This part extends out here because it's going to have a French cleat, and down here the whole thing is going to be surrounded with some trim. And I'm just going to mark center line of my holes. Should probably demonstrate what I'm thinking here. Triple A's, double A's, 18650s, C's and D's. These will be vertical rows going all the way down. And 9 volts. Unfortunately, I don't have a comprehensive set of auger bits for my brace. Looking to get those in the near future, we'll see. So we're going to use Forstner bits and my crappy drill press. After making some test holes in a piece of scrap, I've settled with 1/2 inch for triple A's, 5/8 for double A's, 3/4 inch for the 18650s, 1 inch for the C's, and 1.25 inch looked really close for the D, but as you can tell, it won't quite fit. So we're stuck with 1 3/8 inches. Your bits may vary slightly, your batteries may vary slightly. So testing in a scrap piece of wood is a great way to get a good fit. The 9 volts, we're going to do with a 1-inch chisel. Alright, drill a few of these, show you how I line them up, and then we'll cut to the end product. Because all this drilling would be rather tedious. 3/8 was really close for the triple A's, but it was tighter than I wanted it, so we've stepped it up to 1/2 inch, and I'm just going to let the holes touch. And there we are with our basic holes drilled. For the 18650s, I think I want them to actually put them this way, otherwise they'll stick out past where I want to have a lid. And 9 volts, if we choose to put those in there, will be chiseled in with a 1-inch chisel. Alright, center this, cross mark there. I'm going to shift my hole ever so slightly this direction so that there's a little bit of friction fit on these. To save myself some chiseling, I'm going to keep drilling holes to connect these two now. There we go. Foolishly, I drilled through that one, but it won't hurt a thing. Just pair with our chisel to connect these. Taking the points off initially fairly rapidly, but as I get closer to the outside radius of these circles, I'll go more carefully and make sure everything's nice and straight. Nice tight fit, but I can also get my fingers in there to pull it out. And these dome shapes make sure that there's no chance of continuity between the ends. Alright, for the 9 volts we could drill 1 1/8" hole, and they almost nest in there, but it's a little looser than I like. Or we can use a 1-inch chisel and make a tight fitting hole for them. I'm going to start, however, by drilling a 1-inch hole, just because it's easier than chopping out so much with the chisel. Sever the fibers so we get a nice clean square. We'll come in here with our chisel. And don't start right on your line, actually step out a little ways. And you work on this just like any mortise. Just a lot of the work's been done for you. Avoid the temptation to come in like this. It's okay to pair this way, but try and remove any significant bit will split your wood right in two. Alright, and there is our 9-volt slot. To assist with keeping dust off these batteries, I'm going to surround them with this scrap oak trim and then put a plexiglass top over it. I'd like to do mitered corners, so to figure out the exact width, I'll line this up like so. Come over here, put a piece here, mark that off, and that's going to be my maximum width at the points. I'm going to cut all these pieces to length, and then we'll attach them. I have yet to make the appropriate jig for my shooting board for mitering 45s. However, if we precisely measure and cut in a piece of scrap with the exact saw we plan on cutting our actual wood with, we can get a nice jig for holding at a consistent angle. Now we can use this to guide our saw and hopefully reproduce consistent 45-degree angles. It's much tighter than a miter box you might get at the store because it was made with the kerf of the blade that you're going to use. It looks pretty darn good from here. Cut the mating side piece as well, and then put them together for comparison. Let us check that against our square. Alright, I got the slightest little gap on this inner piece here, but we can fine tune that with the plane. The outside is beautiful. There's my 4 sides. And here it is, all clamped up. You'll notice the bottom sticks out further to support the weight of the plexiglass. Now I was going to make this slide in from the top, however, this unit's not standalone, it's going to be mounted inside another cabinet, so I'm just going to have it affix with magnets. Let's mark the ultimate width of this plexiglass, and then we'll score it and break it over the edge of the workbench. Using a disposable knife because Plexi's hard on knives. Not that I can't sharpen my other one, I just don't want to have to do it prematurely. So I'm taking light passes. Being super careful not to put my fingers over the edge of my straight edge. You only make that mistake once. And once I feel that I've etched a continuous line in there with light passes, I can remove my straight edge and follow the groove I've already put in there with a moderate pass. Don't push really hard, don't force it. That's when you'll veer off to the side or break something or cut yourself. You can keep doing this till you cut all the way through if you want, however, that is not necessary. We're merely trying to put a deep score. Eventually we'll get tired. We need to take our score, put it on a nice crisp edge, and break the excess off. Just like so. To fix the plexiglass cover, I'm going to put small screws in here and then simply adhere some magnets to the plexiglass. If this was a standalone unit, I would totally have this just slide down in here, but it's going to be inset inside another cabinet where this can't slide out the top. I'm going to drill pilot holes. I guess I didn't film putting the screws in, but I think you can figure that out pretty easily. Here's the magnets in action. Again, if you wanted to make this its own freestanding unit, I'd put a backer on the back, 1/4 inch ply, 1/8 inch ply, something like that. But this is going to be mounted in the cabinet. So, for finishing my shop fixtures, fine boiled linseed oil is good enough. Doesn't need to be high gloss, just want to protect it from moisture. So slap coat on here. Wipe it down in about 10-15 minutes. And then apply additional coats once a day for a few days. The other convenient thing is my bench is finished with boiled linseed oil, so I'm just adding to the finish. It's really easy for scraping glue off, too. Make sure you get inside these holes. You don't want the wood holding moisture against your batteries. That would be bad. So that's my prototype Battery Caddie. This is going to be going in a charging station. Stay tuned for that video. Thanks for watching.